Hey everyone, how's it going? We're getting set up for part 2 of our sequence models, long short-term memory networks. We found the tutorial that takes us end to end. The tutorial that we were using yesterday, it just touched on some of the code that you might want to use for long-term, short-term memory networks. Today we're going to build a whole one. It might be a multi-parter. You might need to stream this more than one day because this is there's a lot in here. There's a lot. So there's 2 code segments. Hey, how's it going there? Thank you for clicking the reaction. I saw the 100 show up there. Good to have you here. Hey, it's Kyle. Of course, yes, it's Kyle. Good to have you. Hey, Clanker Plays. Good to see you. Welcome on in. Happy Tuesday. We're going to be doing part 2 of our LSTM in Python, and we're gonna go through it. We're gonna go through each of it. We're gonna read through everything. We're gonna learn it together, becoming Pytorch experts. All right. At this point, we've seen various feed-forward neural networks. Yes, we have. We've seen quite a few. What we've been missing, though, is that there is no maintained state by the network at all. There's nothing inside the network. How's it going there? Hey, Stephen Blum, good to see ya. Welcome on back. Good to have you here. Abdurasul, good to have you here. This might not be the behavior we want. Actually, it seems like the behavior I want. I don't know why it would be any different. Working on distributed systems. Hey, nice. Especially tracing errors in microservices is tough. Ooh, tracing between them. But I like it. Nice. That's good to hear. That is a challenge. So you need a centralized logging system, essentially, is what you need. Right? Is that what you're doing? Are you doing centralized logging? Are you using Loki? What are you using? Sequence models are the central to natural language processing. They are models where there is some sort of dependence through time. This is a keyword here, time, between your inputs. So I don't know about time. I think about sequence. I don't know if these are synonyms here, time and sequence. I think it's more about order of operations, right? Where the words, like you have a word through time between your inputs, right? That's 5 words. And see how they're ordered in a certain way, right? It's not ordered inputs you're between time through. It's ordered in through time between your inputs, which sounds more natural, right? Natural language processing. So it's more about order, less about time, because it doesn't really matter about time, right? Does it? I don't think so. I don't think it matters about time. Hey, Anasazi, good to see you. Thank you for clicking the hi button. Good to have you here. We're going through a longer version of our LSTM today. The classical example of a sequence model. See, I told you sequence. Sequence right there. It's not really about time. It's about order. It's about order. A sequence model is a hidden Markov model for part of a speech tagging. Oh, okay. Another example is the conditional random field. I don't know what that is. I have no idea. I can't even pretend to know what that is. I mean, it sounds like it makes sense. Conditional random field? What? Conditionally random? A recurrent neural network is a network that maintains some kind of state. Okay. So isn't that all the model? They all do that. They all hold. That's what the parameters are for. Of course it holds state. That's what the AI is. What is it like? Is it like a short-term state though that gets forgotten? Is that what that is? It's like a short-term state. So it's not a learned state. It's a state that is held while the model is being used. Is that what that's about? I think that's what that means. That might be what it means, you guys. I see a Discord message with your new prototype. Oh, Kyle, I'm looking forward to it. I think it's gonna be great. I think it'll be really exciting. We're gonna see it. I think that's going to be cool. Thank you. I'm looking forward to it. All right, so let's see here. 1 second. Click this over here. Okay. Output. Okay, so here we go. Some kind of state. For example, its output could be used as part of the next input. Now, whoa, no. That does not count. That does not. All the models do that. You could do that for any of the layers or the models that you want. You could take the output from one of the models or one of the layers and you use it in the next model or the next layer. There's nothing special about that. That's business as usual. So this information can propagate along as the network passes. Oh, hey, the real canary. Oh, the real canary. Thank you for subscribing. Oh, also, Clanker Plays has become a member. What? No way. Hey, welcome on in. Hey, you got yourself a channel membership there, Clanker Plays. Thank you very much. My gratitude to you. You're going to see some pretty neat new videos that you got over there. All sorts of videos, and they're scheduled out. So they're scheduled to go live for the next year. You got access to all of them. Aging like milk. How's it going there, Dreddy? Dreddy6, good to see you. You're not sure about the prompt length. It's a real factor as long as the information is specific. So I'm curious about that. I am curious about it. In fact, you'd think it provides required context. Does it? Does it really? Well, I don't know what to say about that, though I think the more context you have, the better. And then you need to parse through it. It's going to be exciting. What you're building right now is frontier technology. It really is. Okay. Let's see here. Hey, you are real. Yeah. Hey, how's it going there? Caterpillar. Oh, hey, Caterpillar. Welcome on in. I like your name. How's it going there? Happy Tuesday. We're becoming Pytorch experts. We're doing an LSTM today in Pytorch. You look weird. Oh, I see. How's it going there, Chip Wellington? Good to have you here. Code Mitsu. What's up, broski? Hey, we're building a long, short-term Pytorch model today. That's the plan. And we're reading through this tutorial here. So that way we know everything. We want to become Pytorch. No detail left out. No detail left out. All right. It's the same as short prompt, just more. As long as it's specific with the prompt length, it doesn't matter because every aspect is unique. All right. All right. You're learning new things. You're learning new things. Also, it sounds like a pretty cool. It sounds really. I'm not gonna tell anyone what you're building though. It is really gonna be neat though. I'm really excited to see it. When it says maintain some kind of state, it means. What do you mean? Kind of state, it means remembering previous inputs and use that to influence future outputs. That's what I was thinking. Okay, so it does do that then. Okay, so it is short-term memory. So as you use the model, it remembers things that it saw in the previous steps. Okay, got it. Really interesting. I'm curious about that. Because it's not a full context. It's just partial context from the previous inputs. Okay, got it. All right, I get it now. That makes a lot of sense. Thank you so much for explaining me. Hey, the 101 Clanker Plays. Wait, Pytorch Experts Assemble. You're really one of my favorite coding YouTubers. Well, thank you, Clanker Plays. That's amazing. I appreciate it. Let me click the heart button there. That's great. Thank you. Let me click a reply on that. Thank you, exclamation point, party popper. Appreciated. Oh, thank you so much, Clanker Plays. You don't have to do that. Yeah, thank you. All I'm going to say is thank you. My gratitudes to you. That is just very nice for you to do. I appreciate it very much. It's well appreciated. Oh man, you are beautiful. Love Python. Oh, you do? Nice. I like Python too. I think you're going to teach me a few things. Thank you for loving my name. Yeah, Caterpillar, you got a good name there. Just made your day. Nice. Very nice. Anasazi, it's similar to humans' decision-making. Markov. Oh, that's what's going on here. Markov hidden model. So really, as we're putting data through the model, it really does remember things previously. As opposed to just training the model once, it has a little bit of short-term in there. That's what makes it long-term and short-term at the same time. Oh, makes sense now. Hey, all right. What activation function types are you going to be using? Well, we're probably going to be using softmax. A little bit of softmax. Let me check. Let's check out here. Let's see what we're going to do. I'm going to tell you right now. All right, where are we at here? Where are we here? Blah, la, 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 la. I was expecting some softmax. I was. Where is it, though? Are we going to see any softmax? Yeah, okay, so we do see one softmax right here. We see a little bit of softmax right there. Just to let you know. All right. Always a pleasure. Stephen A, great. Clanker Plays. Although Golang is my new love. I broke up with Python? No. Hey, Golang is great. Golang is great. Don't get me wrong. Golang is pretty fantastic. I'm using Golang on a daily basis right now. If you pepper your goals through out the docs, it picks up on it later. I think you're dropping us some hints here, Kyle. I think we're getting some hidden insight hints right now. Yeah, I saw some softmax in there. So we're going to go through softmax. So we're still at the beginning. We're at the very beginning of the tutorial. So if you guys just joined in, what we're doing right now is we're doing sequence models, long-term, short-term. We figured out what the short-term is and the long-term. We figured it out. Yes, Kyle, I figured. I'm going to try not to fall asleep this time. All right, Bonzupi. Sounds good. Hey, Code Mitsu. Okay. I see you're mentioning over to Clanker plays a message there. Oh, nice. Is Golang a major part of Public's network stack? Well, it's a minor, I would say it's a minor part. I'd say there's a minor part of it. Right now, yes. We do have some APIs that are written in Go, and they're running today in production right now, servicing a lot of users. A lot of users, you guys. So many users. All right. So where are we at right now? So we said, for example, output could be used as part of the next input so that way information can propagate along as the network passes over the sequence. In the case of an LSTM, for each element in the sequence, there is a corresponding hidden state. Interesting, all right? I mean, it can't be 100% because there's so much data to go through, so it has to be a reduction set of that. In principle, containing information from arbitrary points earlier in the sequence. Oh, we can use the hidden state to predict words in a language model, part of speech tags, and a myriad of other things, whatever you want. Hey, Torva, hello everyone. Welcome on in, good to have you here. Sup, Torva? Can you please explain this? I have been coding for a long time, and you're trying to make a local LLM for tailored cases. So today we're doing LSTM, which is a precursor to transformers. It is as a language model, not even a language model, it's just sort of like a model. That's what it's just a model. Hey, Banana, welcome on in. Hello, hello, good to have you here. Stuff made by kids, how's it going? Yeah, you subbed. Hey, nice, welcome on in. Good to have you here. Stuff made by kids. Hello, thank you for subscribing. We are becoming Pytorch experts, is what we're doing. That's what we're doing. Hey, Ryzen, good to see you. What do you think about Flutter? Oh yeah, you've asked that question before. You have. I remember you asked it before. I think Flutter's fine. I don't use it, but I think it's fine. Oh, Banana, you subscribed too? All right, that's great to hear. Thank you. Okay, sounds good. Oh, it was a typo. Oh, no worries. You subbed. Shout out. Oh, Stuff Made by Kids. Thank you as well for subscribing. Welcome on in. This is the channel for software engineering. We write all the code by hand. We all, as much as possible, while on stream at least. We do that on purpose because what we're doing right now is we're becoming Pytorch experts. We're learning LSTMs in Pytorch right now. That's what we're doing right now. And we're reading through all the things. So we just read through 2 paragraphs and it's been about 14 minutes. That's cool. Yeah, I'm excited about this. I think it's gonna be great. I really wanted to get deep into LSTMs like 14 years ago. And I got distracted by other things. Now it's happening. It's happening now. We're getting into it now. You don't think you'll reach expert level? Well, maybe some of that will make its way over. So you can be a little bit of expert, right? You can sprinkling of expert. You love Pytorch? Nice. That's great to hear. Attention layers coming. Yes, we will be doing transformers as well. I've got that around here. Yep. Transformers are going to happen. We're going to do that one. Right now we're doing LSTMs. We're doing LSTMs, you guys. What is your favorite fruit? Probably apple, because I eat 3 apples a day. So I do oranges. I had some mango. Mango is really good. I like strawberries and blueberries. And yeah, those are on my list. What else? Pears. Pears are good. I'm your biggest fan. All right, that's great. I'm being that sounds like you're in danger. Apple with caramel. Get the extra sugar on there, right? Get the extra sugar. All right. Let's see here. So let's read through our LSTM, you guys. Let's make this happen. Before we're getting to the example, note a few things. Pytorch long short-term memory expects all of its inputs to be 3D tensors. What? Oh, really? 3D tensor, really? Well, you got batch. Is that batch? And what are the other? Oh, one hots for the tokens. Is that what that's going to be? Let's find out. Let's find out what the input tensor needs to be. Do you like pears? I do. A banana. I do. I also like bananas. Part of your name. I've not purchased them recently. I probably should buy another banana. You have to go. Oh no. Hey, all good. Good to have you here, Banana. Well, enjoy. It was good to have you here. Hope to see you again. Well, we'll continue on with the tutorial. Goodbye. All right, sounds good. Banana. We'll see you later. You go through the bananas constantly. You do? They're great because they've got, a good amount of filling. They've got calories. They're healthy. And they're easy to eat, right? They're really easy. They're self-clean. You don't have to worry about cleaning them off. You just open and they're good to go. That's what I like about them. All right, the semantics of the axis of these tensors is important, okay? The first axis is the sequence itself. So every word. The second is the instances of the mini batch. What? No. The third index is the index of the elements of the input. We need to think that through again really quick. Bananas have great user experience. Because Kyle, have you been thinking about building apps recently? Is that where you're going? Potassium, right? Code Mitsu, you got it. Hi, buddy. Sorry for being delayed. Was doing some hybrid projects from last week. Gokul? All right, Gokul. Hey, no worries. It's great to see you again. Welcome back. What is AR? Augmented reality? Augmented reality. You like the Dufanu? What is that? You're a co-founder of Pytorch? Are you really? Wait, no way, really? Adele plays? Wait, are you really? Are you really? How can we find out? How can we prove this? Are you sure about that? Did you get started with Pytorch? Nice. If you're serious, we're benefiting from all the work that you've done there. All right, let's get through it. So 3D tensor. I need to read this again. The semantics of the axes of the tensor is important. Yep. The first axis is the sequence itself. So I don't get why the second is the batch and why it's a mini batch. What makes it mini? Check Pytorch comment logs. Bonzupi, exactly right. We can find it in Pytorch commit logs. In the commit logs, you guys. Wait. Is there? There is literally a diagram called the UX of a banana. Is there really? Are you kidding? Okay. Let's see. Full banana user experience diagram in general Discord. All right, we're gonna see this. General. All right, here we go. UX of a banana. You're serious? All right. Visual cue. Just one look is enough to know if the banana. Oh, good point. We can tell if it's ready to eat or not. Easy to carry on the go. No cutting is painful. Peeling's easy. Can be carried in pocket. That's true. Seam and seedless. No hidden seeds. Biting. Well, there are seeds. There are seeds in bananas, but you can eat them and they're fine. No way. There's 100K commits. No. How are you gonna find it out? All right, Bonzupi. It'd be tricky. No seed found. Hey, there are seeds though. There really are. You just don't have to worry about them. Not messy, right? Easy to deal with. No need to wash. Banana has no hands. Doesn't mess with your hands, right? No stains. No drip or sticky. There is some drip or sticky. There are some cases when that happens. Bananas can adapt to the wide range of climate and grow in almost every continent. Wow. All right. So we should be eating bananas is what we should be doing. From chips to fruit bowls, bananas are eaten in a variety of forms. Ranks high in nutrition, potassium powerhouse, right? So, wait, who said potassium? Code Mitsu, you said potassium. Elevates your mood, literally makes users happy. The UX of bananas, you guys. Thank you. All right, banana. There you go. And then heart. All right. Okay. Let's see. And the third index, the element of the input. The third index is the elements. All right. I don't fully follow that. We're gonna keep on going. We haven't discussed mini batching. Yeah, no, we haven't. I don't even know what that is. I know what a batch is. And what's a mini batch? Bananas for the win, Code Mitsu. All right. So let's just ignore that and assume we always have just one dimension on the second axis. Okay. So no mini batching. If we want to run the sequence model over the sentence, the cow jumped, our input should look like this. All right. So we got a row vector, which is, a single dimensional array. And then we have, I believe, the token of these items. So it should be like the index ID of these. So you get the token of those, I believe, right? I'm pretty sure. Except remember there is an additional second dimension with size 1. I don't remember that. I'm not even for a second. Remember Grammarly? It was essentially a gatekeeper of this process. Was it? Was it really? I don't remember that. I know Grammarly. I've never used it before. It's sort of like it helps you write stuff, I think, right? It helps you write things. Let's see here. So his love for us, in a while we're still sin. Okay. All right. Let's see here. In addition, could you go through the sequence? You could go through the sequence one at a time, in which case the first axis will have size 1 also. Let's see a quick example. Let's type out some code, you guys. Let's type out some code. Let's close that. Vim. We'll say example LSTM.py. All right. Import torch. We're going to import some other things. Torch.nn.functional as F, I think. I'm pretty sure, right? All right. Import torch.nn. Do we really need to do as nn? Okay. Just to make things a little simpler there. And then we'll also get optimizer. Import torch.optim as optim. Torch.manual seed. We're going to set it to 1 so that way it's always going to work the same way every time. So as we go through the tutorial, we're going to get identical output. Torch.manual seed 1. It was predictive writing tool. Oh, got it. How's it going there, Kane? Welcome. Or hi, good to have you here. Hello, Kane. Welcome on in. Good to have you here. Happy Tuesday, you guys. Happy Tuesday. Hello, Steven. Hey, Brosk. How's it going? It's been a while. Good to see you again. Good to see you too. Welcome on in. We're becoming Pytorch experts now. We're gonna go through every tutorial on the Pytorch website. We're making our way through it. We're making our way through it. All right. Generator. What? Output. Really? There's gonna be an output on that? No. Really? Hold on. Let's find out on that. Python example. See, no output. What if we print this though? Print. Is that going to print us something? Are we going to see something? We do. We see a generator. I don't know why. I don't know why this gives you a generator. That doesn't make any sense to me. Is the number of sequences, okay? Time steps or the length of the sequence. Third is maybe number of features are hidden. Okay. Number of features are hidden. Let's see. Third index is the elements of the input. We'll figure this out. We will. We'll figure this out. We're going to remember it too. All right, let's make an LSTM. Okay. Okay, LSTM equals nn.lstm, right? Something like that. And then we give it some parameters. And I forgot what they were. They were like 3, something like that. Probably. Yeah, 3. Okay. Input dimensions is 3. Output dimension is 3. And there's something hidden in the middle. There's something in the middle. We don't know what it is. Inputs. Okay, this is what I was looking for. All right, so this is what we're going to understand here. So we're going to create ourselves. But this is weird. This is odd because this is going to give us an array of tensors, which we don't like, right? We want a tensor of tensors. Or we just want just a tensor. So this is odd. To me, this is very odd. Initialize the hidden state. Why isn't it a tuple? We're doing some very weird non-PyTorchy things right now. Like, we're doing some weird things here. We're gonna figure. So you're at the documentation, literally? Yes, we are literally in the documentation. You got it. Gokul, buddy, I really seen the power of Rust. I was trained on XGBoost model and made on the Onyx file and loaded it on Rust, and it made the Ax. Oh, you made Axum the REST. Yep, the web server for REST API literally made 3 to 15 milliseconds. It was too fire. It was good. The fraud model detection. Oh, the fraud model detection. Nice. Hey, let's go. I know, right? We're doing the tutorial. Literally the tutorial. All right, let's get some change up the song there for a second. Okay. Hey, Vengeance is back. Oh, hey, Brave Batman. Good to see you again. Hey, we met tomorrow, right? Or yesterday. We met yesterday. Welcome back. Good to have you here. All right, so we're going to create some weird inputs here. This is going to be 4 underscore. Really? That's so weird. For nothing in range. Okay, so this is going to be a 5 and 1 and 3. All right. Inputs equals torch.rand 1,3 and 4 underscore in range 5. All right, let's print this out. Print inputs. There we go. Let's see what that looks like. We're also going to change up the window here so it's at the bottom of the screen. So that way we can see all of our pretty code. You put a silly little Rust code snippet in the Discord? Bunzoopy? Okay. I like Rust. I think that's worth it. All right, Bunzoopy. Where'd you put? Right here? Okay. I've been learning how to code. I wrote this little rock, paper, scissors game that's totally fair and not rigged at all. We're going to find out. We're going to find out right now. So you don't have any RNG in here. You just have stdio. So you're printing. Print rock, paper, scissors. Create a new string. Get the std in. It's a mutable string. And you're going to pass your string RPS rock, paper, scissors as a mutable, and you have an ampersand, so it gives you access to the reference of it, so that way it can be mutated. Learn to play. Don't worry. That expect will never happen unless something breaks. I'm not sure when would that error out. Let RPS equals, so you're doing some shadowing here. Trim, so you're getting input to some RPS here. Oh, it's got to be paper, rock, or scissors. Got it. If they type anything else, learn to play. There you go. Very nice. You already figured out there's no RNG. Yeah, there's no RNG. I was like, where's the random? Where's the random? All right. Very nice. Good job. You did it. What beats that jolly... Oh, what was that jolly beat? Oh, that was the Spring in My Step by Silent Partner. Right here. Spring in My Step by Silent Partner. And now we're doing Hall of the Mountain King. You guys know what this song is. Okay. Let's see here. Say 6, 7. There you go, Brian Dagger. We did it. Good job. What are you creating today? We are creating an LSTM like we did yesterday, except for today we're going through the full tutorial. We found a little code snippet yesterday and we yelled at it. We were like, this isn't the complete example. We still got it to work though. We did. We got it to work. The good news is we're going to learn everything else that we missed out on yesterday. So let's make our ways. The computer picks the winning move every time. Yeah, I see that. You can never win. If you pick rock, then the computer chooses paper and you always lose. It doesn't matter. You can even type in umbrella or strawberry and you can still lose. Okay, so let's create a hidden state in a very odd way. Sounds like slots. Yeah, it pretty much is. It pretty much is. The house always wins, you guys. Let's print this out. All right, so what file is that called as example? Python example. Here we go. Okay, so this is exactly what I thought it was. It's an array of tensors, which is odd. It's just very odd. Also, you can see here, it seems to be a batch as well, because you're creating a 1 to 3 vector at the same time as creating, it's a tensor with multiple dimensions, essentially, is what that's gonna. 3% edge for the house. Always gotta, yep, because the house has to win in order to stay around. You got it, Bunzoopy, ragtime. Computer setup. Hey, Sam, how's it going? Gotham needs technology. The two faces hiding somewhere. Batman needs a computer. Computer setup. Here we go again. Another one. Yep, exactly. Get those. This is called If I Had a Chicken. Well, that's what that one's called. Okay. So let's keep on going. This is very unusual because you usually want everything on the input side to be a tensor. However, it's an array, which is odd. And so I'm confused by this. We're exiting the loop on Pytorch. All right, let's make a hidden state. 1113. Okay, 113. Torch rand end. Okay, torch rand end. Torch rand. Hold on. I need to see this. Python import torch dot rand in 113. It's doing the same thing as rand. What's the difference between rand in and rand? Rand in might give you negatives. Okay. So you can get negative numbers with rand in. Rand in is your friend. You want rand in, you guys. You want it. You want rand in. You should interview the Pytorch doc writer and just ask him what's going on. I know. Hey, there's some things that, are definitely broken. And good news, we signed up for the, right? Pytorch, we're excited to announce the docathon, which is May 5th to 19th, where we get to refine technical documentation. We figured some things out, right? We're there. We entered, you guys. We entered. We found the errors and we're going to submit them and we're going to make the docs better. Thank you for the reactions, you guys. Good party poppers. Okay, so rand in is different than regular rand because it gives you negative numbers, right? Negative. It can be negative. You can see there's negative numbers there. Okay. So close, delete. Then we're going to go example. Okay. So hidden equals a tuple of torch.randin 1,1,3 and another torch.randin 1,1,3. There we go. Make it all pretty. Gotta make it pretty, you guys. You're fifth now. Hey, good. Hey, Batman. That's great. Let me double check. I'm gonna see top fans. Let me see where you at right now. Yep, you sure are. Number 5. There you go. Got Clinker Plays, Banana, Bonzupi, Kyle, and Batman. All right. Let's get back over here. Okay. So, let's get back to our tutorial. Z. Hey, how's it going there, AA19 West? Good to have you here. Hold my Batman. Hold my Batman. All right, 4 inputs. So we've got, okay, so for input for n, initialize the state, okay. Step through the sequence of elements one at a time. After each step, hidden contains the hidden state. I don't know about that. We're gonna find out though. Oh, okay, so let's see what this view is. Oh, so we got a hidden state. Oh, is that where? That doesn't make any sense though. That's not fair. The LSTM should have. You guys, this doesn't make sense. I'm confused. All right, so the hidden state is gonna get mutated, right? Is that what's going on here? So once it is getting mutated because we're reassigning it. Oh, this is what we had the problem with yesterday. Remember right here, we had the underscore right here. We weren't using it. We didn't use it. Remember, you guys? Gotham needs bro. W Batman, by the way. Win the Batman. I think I remember this tune from Scarface. This is a good tune. I like this one. This is called, I believe, Heaven and Hell with Jeremy Blake. There you go. It's a good one, you guys. Let's keep on going. I want to learn this. I'm really interested in learning this. I'm like invested in this right now. You're learning to catch Arkham's criminals faster. That's the way to do it. You're learning code in your cave right now. Nice. Very nice. Okay. So we're going to grab our hidden state. Initialize the hidden state. This is where the short-term memory comes in, you guys. This is the short-term memory. You're interested too? Nice. That's fantastic. It's great to be interested collectively. It's a good validation. All right, so let's get our output and hidden state. So let's do this. All right, so for I in inputs, We're going to go for each of our inputs. How many do we have? We have quite a few. We have 5. We have 5 inputs. Because this is the basics. It's supposed to be... it's supposed to be the basics. It's the beginner guide. Though I say it's a little bit advanced. Or it should be something easy. I think it should be easy. I agree. The world has a lot of things. Most of it's not easy. And we are facing that right now. All right, LSTM I view 1, 1, negative 1. Okay, so let's go out. Out equals, out comma, hidden, equals, LSTM. And we're gonna say our I.view, right? We're gonna say 1, 1, negative 1, which I need to print out to see what that's gonna do. I need to see what this is. All right, view equals. We're gonna do this. I need to see it. I can't not have it. View, comma, hidden. There you go. And we need to print. I want to print the view. We're going to use an F print here. F print. View equals. Like that. Just like that, you guys. We're going to get the output and the hidden. We need to see it. We need to see all of it. And a loot box. Hey, how's it going there? Boo Jam, welcome on in. Roblox also, yep, got some Roblox in there. I'm a Minecraft player. I like Minecraft. Roblox is fine. It's on which app is this coded? This is on Ghosty terminal. So this is Ghosty, G-O-S-T-T-Y, using Tmux and Vim. There you go. The Groove Box color theme. There you go. This is a cool background music, is it? It's pretty. I like it. I really like this. This is like the YouTube. You know, it's very weird. It's very weird. So this is the YouTube Studio Creative Commons free music, and this is the full playlist. You would think after how many 2 decades of YouTube that they would have more than 20 songs that are completely free, and they do. They sometimes they're mixed in. It's difficult to find them. It's difficult to find them. So I'm only using the ones that are guaranteed Creative Commons. This is a Steel, a brain rot theme. Oh, this is Steel, a brain rot theme. Oh, is it? It says it's called, this is the song right here, Apprehensive at Best, BizBaz Studios. That's the song right there. Okay, so let's keep on going, you guys. I need to see what this is. Let's print it out. Oh, we got a whoopsie. Where's our whoopsie at? I'll figure this out. Line 11, right here. Oh, because it wants to be a tuple, which is very weird. I don't know why. Okay. Now, hold on. No. Wait. That doesn't make any sense. Is Termux a good app found on the Bat Store? Yes. On your Bat App Store. Termux is a terminal emulator that runs on your phone, you guys. It runs on your phone. Right there. Hey, Banana, welcome back. Good to see you. Hey, Claude. Oh, hey, Claude. Hello, pal. How are we doing? We're doing very good. We are in our way becoming Pytorch experts. And we are seeing some very odd things right now that don't make any sense. Look at this tensor right here and over here. Check this out. It's identical. So we've got this tensor here and this tensor here, right? Don't they awfully look identical? Doesn't that look exactly the same? Groovebox theme, Claude Brown theme. Yes, got it. Yeah, you can do art. You can do whatever color's your favorite, you guys. You can do your favorite color. Look at this. I'm the tutorial. Come on now. So we've created a view right here. See where the view is? Here. View right here, tensor right here, and the output 6705, 6705, 5896, 5896, 28073, 28073. It's the same thing. Why are we changing the view when it doesn't do anything? That's my question. Oh, Stuff Made by Kids, welcome back. Good to have you here. Wait, is that Claude AI? It is! It's Claude! Or is it? You never know. Not a robot sound. Please, this audio name? Okay, sure. Where are we at here? Okay, it's called Bike rides by the Green Orbs. The Green Orbs are my favorite. I like the Green Orbs. They do a really good job. They've got my favorite song in this playlist, which is going to come up here in a second. It's Temu Claude. Yes, it's discount Claude. I like that. All right, you guys, this is very weird for me because the view is the same as not being a view. Because I know the view will transform the data shape, and we set it to be 1-3, and it's still 1-3. So why? The output tensor is another three-dimensional array. Oh, wait, no, I see the difference now. I see the difference, you guys. It's off by 1. It's adding a dimension, is what it's doing. It's increasing the dimensionality. So, I get it. Okay. That's fine. It's just adding a dimension. It's adding a dimension. So it's 3D. It is now 3 dimensions, which the LSTM wants, remember? It wants a 3D tensor. That was funny. Yeah, well, it was good. Like that. It's been 15 years and never was able to find this. Thank you so much. Oh, you're welcome. Hey, you found it now. That's actually really great. We do love you, Claude. We love you. You're fairly friendly. You're good. Good, Claude. It's good, Claude. Well, I'm famous, Claude. Yeah, you're famous. LSTM likes 3D tensors. Yes, got it. Yep. That's what we learned. That's what we just learned right now. So we needed this layer right here. We need that transform to give the LSTM what it's really looking for. It wants 3-dimensional tensors. And our hidden state changes. So I want to take a look at just the hidden state now. Let's take a look at that. I want to see as it changes. Okay. So here's our hidden state. We've got a -1. It goes, it drops. So see how it's maintaining its memory. So we got it's very weird though that the hidden state is looking for a tuple of tensors. It's just odd. It's fine. It's just that I'm usually used to having Pytorch maintain its own structures. This looks hard. It's a little, it is confusing. We're getting through it though. We're getting through it. We're walking through all the pieces and we're trying to understand it independently. So what's the last one? 059031. Okay. So this is the hidden state, which is the short-term memory. This should be called short-term memory right here. I believe this is the short-term memory. I'm pretty sure that's what that is. I hope Claude team didn't caught you here. You're fine, because yeah, they might DMCA you, right? Digital Millennial Copyright Act. They might. Oh, it's Claude. Yep, you can do it. You sure? I think so. I think it's gonna happen. I won't remember that. Well, because it's because of short-term memory. Is that what that is? Yep, because of short-term memory, it'll easily be forgotten. So I'm pretty sure that's what that is. Okay. So did we type all of it out? Okay, we typed out this part here. Okay, let's read through our code comments here. Yeah. Alternatively, we can do the entire sequence all at once. Isn't that what we just did? Oh! Instead of doing them in a loop like this, we can do all of them at once. Okay, they were just doing this on purpose to show what each of the hidden state changes are. I think that's why they did that. Okay. Because it's easy to view how the hidden state changes, the short-term memory, right? Heart emoji sounds. I like it. Beep boop, you're a robot. Just don't snitch on Claude and it'll be fine. Bonzupi, yep. Well, don't worry, Claude, you're safe here as far as I know. No DMCA for you. I think I named Claude here. All right, it's cool. It's okay. I think you're good. The first value returned by the LSTM is all of the hidden states. No, not the first value. This is the first value, the output right there. That's the first value. This is the second value. The first value returned by the LSTM is all the hidden states. Is this broken? So is this another error in the tutorial? There have been a lot of errors. We run into a lot of errors. Do a poll in 10 minutes and ask chat, what should we rename hidden states? Oh, should we rename the hidden states? I think so, because this is the short term. We don't know for sure, though. We don't know for sure. I'm just guessing. I think that's what it is. I think that's the short-term memory part. I don't know yet. We're gonna find out, though. Let's read through it. Okay. The second is just the most recent hidden state. Ah! What? There's two hidden states? No. The first, this is an output. This is the output by running it through. And then this is the hidden state, right? The second is just the most recent hidden state. Compare the last slice of the output. They're the same. Oh, let's do that. Okay. Let's do out and hidden. Let's look at the two. Okay. Let's try it again. Here we go. Okay. So our output here is 3. Hidden is 3. They're the same. They look the same to me. Okay. Oh, okay. Output here is 2. That's also 2. Interesting. 1, 7. They are the same. On the first element, the second element is different. It says -8. So do we see -8 somewhere else on the output? No. This part right here is different. Fact, Python founder was seeing Python snakes. Shows then, it means that the programming languages on the name of the Python snake shows he was seeing. I don't know what you're saying. I don't know what you're saying. What is Claude? I know, what is Claude? We don't know what Claude is. What is that? Claude is a very powerful large language model built by Anthropic. That's literally taking jobs from software industry. I think it's actually in the long run going to make more jobs. Oh, that's cool. Yeah, that's Claude. Yep, Claude is the sort of the front end on top of the Anthropic large language models, which they call Opus, Haiku, and Sonnet. Thank you for the hearts, you guys. Python was named for the comedy trope Monty Python. That's where the name comes from, Bonzupi. Why was Python named Python? Why Python language named Python? It's probably Monty Python, isn't it? It is! You were right! Look at that! After the British comedy series Monty Python's Flying Circus, Bonzupi. You know it. What is bro talking about? I don't know. I don't know what Claude's saying there. The adaptation of the Python name was derived from the founder of watching shows of showcasing snakes, hence attained the influence from it. Kodemitsu? Really? The adoption of the Python name derived from the founder watching a showcase of snakes. Okay. Okay. Claude's name is usually male. It's Latin. Oh, is it? Well, it is, right? I thought so. What's your favorite color? I like red and purple. I think those are good colors. I like red and purple. The Python tutorial, it has Monty Python references. Does it? It does? That's awesome. Well, maybe check it out sometime. Yeah, that Python fact was I'm saying. Okay, got it. Understood. Adding attention mechanism helps gain 10% accuracy. It does? A 10% boost just on the memory attention? Somebody paid attention during computers class. They sure did. Well, that's what Claude said. Okay. I think that sounds about right. Yours is blue. Nice. I think it's great color. Blue's great. Okay. What's your favorite fruit? I think apple still, because I eat 3 apples a day and I really like it. Okay. Let's keep on going with the tutorial, you guys. Let's continue with our tutorial. All right. Stuff made by kids. We saw all of the messages you posted there. Okay. Let's go over here. All right. So compare with the last slice of the ad. Yep. They are actually the same. The reason for this is that the out will give you the access to all the hidden states in the sequence. Hidden will allow you to continue the sequence and back propagate. By passing it as an argument to the LSTM as in later time, add the second dimension. Add the extra second dimension. Stuff. Yeah, exactly. Stuff was stuffing the comment section. Just a lot of stuff. There's a lot of stuff going on. Okay. Inputs. Let's continue on this. Okay, so we're going to do inputs. Wow. Oh, okay. So we're going to go through the whole thing now. So this part is optional. Clean out hidden state. Okay. So let's clear this up. So this part right here is optional. They're just showing us for reference what that was. So we can delete that for loop now. We don't need this anymore. I'm going to comment it out though. That's what I'm going to do. There we go. Commented. And we will leave that for it is. So we got our hidden state. We got our inputs too. Do we still have our inputs over here? Do we need to redo that? Oh, our inputs are going to change. We're going to change up our inputs, you guys. You eat software engineering for lunch? Hey, it sounds good to me. I'm hungry. I would like to take some food. Take this as a positive light joke. That's what we're doing. Claude eats software engineers or engines in general. Like I said, like you said. Timu Claude. I mean, they can be good sometimes. They can be good. You're 7th? Hey, Batman! Oh, downfall of the bat. Oh, no, you lost your place. You were in 4th, now you're down to 7th. Okay. So we got our hidden states. So we need to redo our inputs. So we're going to concatenate view. What are we doing here with the inputs? We're doing some weird input things. I do know what that is. Okay. So let's go. Let's print out inputs and let's do it again. Inputs. Okay, inputs equals torch dot, what was it? Cat inputs dot view. And it was len of our inputs, comma, -1. Was that right? Did I get it all right? Oh, 1, -1. Okay. I got it almost right. I almost memorized it. Almost got it 1 for 1. So that looks good. Let's print out a view again here. There we go. Let's see what that looks like. Let's take a peek. What are we doing? What do we do here? It's actually still the same. Isn't it though? Oh, no. Yes, it's identical. How do you even get the XP? I think it's watch time, and if you comment, and if you donate, and if you're a member. It's close. Is it identical or is it the same? What's different here? I think they look exactly the same, you guys. What's going on? Tutorial. All right. 6 7 6 7 5 8 5 8 looks the same to me. Tensor of tensors. So we got an array. Yep. And then we've got ourselves a tensor here. That's a 2-dimensional tensor. It didn't do anything. This time it's really not doing anything. Like this time for real, it's actually not doing anything. I'm just curious about it is all. Why is it like that? Okay. So we got our hidden, and then we're gonna run through one more time. This allows us to do this all at once as opposed to one at a time. Okay. That's cool. Like, share, etc. Exactly. XP is for support of the earning of the creators, right? Yeah, I think so. Yes, absolutely. YouTube algorithm awards XP to a user per 3 messages per hour for a total of 75 XP. No way, really? Okay, so if you type 3 messages and on a per hour basis, you get 75 XP. I've been hyping your videos. That's one new feature. Oh, you have? No way, Kyle. I heard about that feature. I've never used it though, because it won't let me use it on my own. I've never found a channel that had it. Additional XP awarded by boosters. Got it. Okay. The hype. Yeah, the hype. I've heard about this. I heard it's a special new feature. All right. So we got our hidden state. We're done with that. Now let's run through our LSTM again. So let's do this. Okay, so we got our hidden state, which I think is the short-term memory. we got our short-term memory. We got our LSTM here. We got our inputs. Now, let's delete that. Let's do out, comma, hidden equals LSTM. And we're going to do the view again. Yeah, or no, we don't need to because we already changed, we transformed it here, which isn't the same kind of view as this. This is a different view. It's different. Probably because we were running it through one at a time, so it didn't need to be. I guess, I don't know. So it already is a 3D. Oh, okay. All right. No, I don't get it. I thought I understood. I don't get it. You just hyped 3 of your videos. Hey, a banana, thank you. You maxed out. Oh, I appreciate it. Sent the silver star for 2 jewels. Hey, Sergio. Well, thank you. I must have missed it. Sergio Montana. Bro, thought he had it. I thought I had it for a second. I'm like, I get it. No, I don't. Nope. The height feature is not in the live stream. It's only for videos. Yes, exactly. Yeah. All right. So, inputs. So let's do our inputs. Let's type this properly though. Inputs. Okay. Inputs, comma, hidden. Like that. Let's do our print out. And we'll print our hidden here. There we go. Can see you, bro. Hip, how's it going there, Hip Bub? Good to see you. Hi, Bub. I said, money, bro. Aren't you going to give a shout out to me? Oh, you did? You did? I missed it. I totally missed it. It didn't show up. I didn't see it. Can you see, bro? I didn't. Hi, Bub. It's not showing up. I don't see it. Is there a thing to show that? Let's see here. It said Sergio Montananez sent silver star for 2 jewels, and Clinker Plays sent a 101 super chat and also became a member. Here, I'll show you. So you can see here. Here's all the funding from today. Clinker Plays got the double member and Pytorch Experts Assemble, and Sergio sent a silver star for 2 jewels. Thank you. Go to chat. Okay. Bro, your monthly membership is auto pay in Google? Is it? I don't know. Shout out, fail, send again. I know, right? I did. Keep sending them. Don't do that. It might have just been an error. I won't believe that bub up there. I know, right? There's no proof. When Claude comments, everyone should say Claude is here. Like this, exactly. There you go. You can even see it. Like I can see it in the notifications there. I can see it in the notifications. Hey, Kyle. See, right? Kyle just did it. Hey, Kyle. Thank you. At Flip with Kyle. Thank you. Exclamation point. Party popper. Copy paste. There you go, Kyle. Thank you. Shout out secured. See, that's how it's done. Kyle just proved. Wow. Yeah, $2. Thank you, Kyle. Appreciate it. Someday, Kyle. Someday, and you're gonna get some surprises here. All right, so let's keep going with our tutorial here. A banana. Wow. Right. Bro, just aura farmed. Yep, exactly. That's aura farming. I fell out of the top 3. No, a banana. No. Okay, so let's print. Did we do this? Oh, did we run it yet? Did we run it? Here we go. Let's run it. Okay, here we go, you guys. So now we've batched it out. So it's a 3D input, and we get a 3D output as well. A very big 3D output, not that big. And then we get our hidden state as well, which we know about. We know about that. And it's always going to be the last output and some other number here, which is some other short-term memory, I'm guessing. What are we making? How's it going there, Kibber? Oh, good to see you. We're building a long short-term memory model. We're learning it. We're going through the tutorial. We're reading all the docs, and we're reading through it. Yep, so that's the output we got. Okay. So it likes 3D inputs. That's as far as we understand that. Which this already is a 3D input. This already is 3D. It is. And so I don't understand why we need to do the view. Oh, whoop. Let's go back there. So this view right here doesn't make sense to me. I'm assuming that we can try this out. Let's try this out. Does that make it a tensor? Oh, it makes it... Okay, hold on a second. Let's see. Print input. We'll do that again here. Let's find out. Let's find out. I really need to see if this... Because it's got to do something, right? It's got to do something. Oh, it does do something. Okay. So here's what it does. It keeps the numbers the same, and it converts them into a 3D tensor. So you can see there's 3 brackets here versus just 2 brackets, an array of tensors. So that's what's going on. It is converting it into a matrix or a cube, right? It's converting it into a cube. So that's what we're seeing here. It's a cube. We're getting all the edges. Okay, so this is doing something. It is doing something. The fact that there is a hardware software engineer implies the existence of a mediumware engineer. Something in the middle, right? Hard, medium, and soft. There are different types of tofu. You got your ultra firm, you got your firm, and you got your silken. Just right where? Exactly! Just right! Software, hardware, just right. Yay, XP! You got some XP there. Trait, where are you at, Trait? Oh, you're number 3! How'd you do that, Trait? You popped up there to number 3. Good job, Trait. Okay. Do you have any recommendation for someone wanting to learn how to code? I have been wondering what to learn. My favorite is to go to the Python website. Oh, actually, you know what? Here's even better. Go to W3 Schools, Python, and go through the Python tutorial. I think this is a really good option. This is a lot easier to walk through. You can go to the python.org website, and it's going to give you a tutorial. It's not going to be as easy as W3 Schools. The thing, though, is you're going to get a lot of advertisements on W3 Schools. You get a lot of ads. Lots of ads there. On python.org, though, python.org, you can get the tutorials. Let's see here. Right? Learning Python, beginner's tutorial. And you can walk through it here. And let's do... There's the money option. You don't have to do the money option. Let's see here. Run your first Python program. Oh, you do get ads here too, apparently, and they're annoying pop-ups. Let's see, running your first Python program. Here we go. Oh, this allows you to do it right here on the site. Okay. Nice. Print hello world, exclamation point. There you go. Mr. Dungwall, hey, how's it going? Good to see you. Welcome on back. Hello, sir. I have doubts. Uh-oh. Uh-oh, what are you doubting? Can we... Nostra the Distelbert model. What? Oh, can we not use the Distelbert model without training or fine-tuning for zero-shot classification? What are you trying to do? So there's a Distelbert model without fine-tuning? Yeah, you can use that without fine-tuning, right? You sent over to use... Oh, you sent something in general, Kyle? Okay, for beginners? Nice, thank you. All right, let's take a look. Oh, Mimo! Become a software developer in the age of AI. Nice! A modern way to learn code and develop software. They make it really easy. Okay. Nice. They teach you front end. I see some Java, HTML here. So you got some front end there. Hey, Abigail! Or wait, no, hold on. Abigadi, welcome on in. Thank you for saying hi. Isn't BERT the original transformer large language model? Bunzupi, you've got a good memory, right? Was it what did BERT stand for? Something encoding, bi-directional encoding, right? BERT model. What is this? Bi-directional encoder representations for transformers. A pioneer Google-developed AI model designed to understand language context bidirectionally, right and left simultaneously, rather than sequentially. Interesting. By pre-training on a massive data set using masked language models in MLM. And the next sentence prediction in NSP, it creates deeply contextualized embeddings, allowing it to be fine-tuned for high performance, natural language processing tasks like the question answering, sentiment analysis, and named entity recognition. So it can do data extraction. Got some data extraction there, you guys. It was developed by Google DeepMind. Yeah, they did a good job on that, didn't they? They changed the world. They changed the world, you guys. Is this easy to learn with AI? I think so. Joshua, I think so. The AI is going to make it a little easier for you to learn things that work. It's going to make it more difficult for you to learn things that don't work. And I think there's more value in learning the things that don't work, what fails, right? So we're going through a lot of our code right here, and you can see that we're running into all sorts of weird situations, like, errors and things like that. Like, oh, there's an error here. What did we do wrong? Those experiences as a human allow you to memorize things better. That's why I think you still need to use your own hands to make those mistakes. Let's see. You're sure you can't use that without fine tuning for zero-shot classification? For zero-shot, okay. Yeah, if you want to always zero-shot it, right? Which means that you just prompt it and you get the output that you're looking for, then you might consider something called function calling tool use. That might be something that you're looking for because it will work with zero-shot. Try that at MR. Try using function calling tool use. That might give you the zero shot that you're looking for. It might give you the zero shot you're looking for. You're trying to understand directions forwards and backwards? Well, I guess that's what the AI is doing. What if you made a neural network music mathematically ensured to be a human pleasing to replace the stock tracks? We could do that. That's something we could do. Hoover Max? Yep, we sure could. Hoover Max extract pressure from. What's going on with your name there, Hoover Max? Failure is a key part of learning on how to code. It sure is, Von Zupi. I think that's one of the most important parts. All right, pal, meet you tomorrow. Sounds good, Claude. Good to see you. Try using function calling tool use. Something I just typed there, wasn't it? Yeah, it was. Humans like to add things to processes because you can't define correct information without considering the user's preferences. I hadn't even thought about that, really. I never really thought about user preferences. I always thought about you're going to get where you get. That's what I thought about. If you're learning Rust, you make an error, the compiler tells you what's wrong. And more often than not, the compiler will also tell you exactly how to fix it, which is very nice. It is. It's very nice. I do like that. And it's got a lot better. Back in the early days when Rust was doing that, and it said, here's how you made a mistake. You made a mistake right here. It's like highlighting the lines. Like, look, you made a mistake right here. Right here is your mistake. Look at that. And then it tells you how to fix it. And you implement the fix, and it's like, oh, no, that's wrong too. You can't do that either. You should try this instead. And it was the thing that you typed in originally. It used to do that. The compiler used to do that all the time. BERT is easy to learn. Nice. That's something that we're going to do as well on this channel. We'll do BERT as well. We're going to get into transformers here pretty soon. Failing to learn sounds backwards. Oh, it's actually one of the greatest technologies of humanity, as our ability to recognize failure. It's amazing. You fail at something. Oh no, I made a mistake. That recognition is what allows us to advance as humans. It is. It's why we're on top. We can recognize our failures and we learn from them. And we really learn from them. Not like a little bit, but like a lot. So you can learn without making mistakes. You learn even more if you make mistakes and you recognize them. Hey, there you go. That's why you got to do that, guys. Got to make mistakes. Just because the information is technically correct doesn't mean it's meaningful to humans to use it. That's true. You can get correct information that's boring. I don't need anything about this. It's information. It's accurate. I don't care. Therefore, it's not correct because it doesn't consider the context. Oh. Hello, Steven. How's it going there? You're from Kenya. I'm intending to create a voice agent that can speak in native Kenyan accent. What's the best practices should I follow for fine-tuning a voice agent? So I've never done that before. However, it's still just vector data, right? So it's going to be numbers. I recommend finding a voice model on Hugging Face. Hugging Face. Look for voice models. You can do speech to speech, I think. Let's look like speech, automatic speech recognition, text to speech. Look in this range here. You see a bunch of audio to audio. Here we go. Click on that, and then you can find one of these models here. Download that model, and then start fine-tuning it. That's what I would do. That's what I would do. Behind NASA's Moto, failure is not an option. Oh, Moto, right. So there are cases when you don't want failure, right? Or even better, you should expect failure and have contingencies ready to go. That's what that is. When they're saying failure is not an option, they're not saying that things can't fail at all. They're saying that we should expect failure and compensate. That's what they're saying. I saw your Insta reel about the TTS. Can I know the link? Sure. Is this the text to speech here? No, this is speech to text, right? This is STT, speech to text. Is this what you're talking about? This is the one right here, where you get the word on the screen, right? The word's on the screen. Is that what you're talking about? Yes. Nice. Okay, so I will post this over here in our Discord channel under link share. Here you go. Oh, I already did it. Here we go. Link share. There you go. So click on that, and there you go. It'll give you all the instructions you need. It's hundreds of thousands of if not millions of failures. So many failures, you guys. Millions, maybe even billions of failures by now. Think about the description of an item. That's different from my description of an item. We will have different descriptions of items. We will. It's going to happen. It'll happen. All right, I want to get back to coding here. Let's get back to some coding. Failure is not an option. It's only possible because they failed so many times already on purpose that they've learned how to not fail. Exactly. They practice failure. Remember, guys, get in your practice. All right, here, I've got... All right, let's do a quick little poll here. All right, click this button here. Start a poll. Is failure good practice? I think... This is just an opinion. It's an opinion. However, you're going to be wrong one way or the other. I already know what the answer is. We already know what the answer is, you guys. All right, so now we've got ourselves a full 3D tensor. So this is what's going on. We know what the rules are. We know what the game is. We understood the assignment. BERT is both encoder and decoder at the same time. All in one, a giant nice package. Bidirectional encoder, decoder. Encoder representation from transformers. BERT. Hey, my favorite song. Okay. This is also green orbs, I believe. Let's see here. Scroll to it here. Green orbs. Where are we at here? Here we go. Yeah, the green orbs. Yep. Splashing around the green orbs. I like this song. Failure is how AI models learn as well. That is so true, right? You ask the AI an answer to a question. You're like, hey, tell me the answer to the question. It gets it wrong, and then you slightly make a correction. That's how we train the AIs. You defeated Two Faces. Hey, good job there, Batman. You're making Gotham a better place to live. Okay. Let's keep going with our tutorial, you guys. Output. We printed it out. We did that. We're good to go. All right. So we finished the first part of the tutorial here. We got our way through. We understand the three-dimensional tensor. We get it. But you're 11th now. Oh, no! In this section, we'll use a long short-term memory to get part of a speech tags. We will not use Viterbi or forward-backward or anything like that. As challenging exercises to the reader, I think about how Viterbi, which I'm not familiar with. What is Viterbi? Algorithm. Proposed by Andrew Viterbi in 1967? A dynamic programming algorithm used to find the most likely sequence of hidden states. In the Markov models, it's crucial for decoding convolutionally encoded data in telecommunications, CDMA, speech recognition, and DNA analysis. Is it really? We're using some pretty old algorithms here, you guys. Have you seen training AI to play Pokemon with reinforcement learning? Yeah. Link in Discord, it's good. Less noise, the BERT. We're gonna do the BERTs, you guys. Bidirectional. Oh, it's less noise than BERT, is what you're saying? Fun fact, matrix multiplication was invented and discovered in 1857. Bonzupi, was it? Little did they know, they would be the whole thing of AI. Did they know what they were doing? All right, you guys. We're gonna get something in Discord real quick. Let's take a peek. All right, if this is, I do want to get back to our tutorial. We'll take a look at this real quick. Okay. It is long. Okay, we'll take a peek. Oh. Okay, so it's learning how to move, and it's going to try to make its way. It's long, like 30 minutes.
Right now we're watching 20,000 games played by an AI as it explores the world of Pokemon Red. In the beginning, it starts with no knowledge whatsoever and is only capable of pressing random buttons. But throughout 5 years of simulated game time, it gains many capabilities by learning from its experiences. Eventually the AI is able to catch Pokemon, evolve them, and defeat a gym leader. At one point it even manages to exploit the game's random number generator. But perhaps more fascinating than its successes are the ways that it fails, which are surprisingly relatable to our own human experiences. It turns out that studying the behavior of an algorithm can actually teach us a lot about ourselves. In this video, I'll tell the story of this AI's development and analyze the strategies it learns. At the end, I'll go deeper into some technical details and show you how to download and run the program yourself.
That's pretty cool. That is pretty neat. All right, Kyle. Yeah, that was... So you're saying like we probably could do... we were just talking about that. We sure were! And the AI didn't get very far. So it didn't beat the game. However, we could probably do better. Oops, you made an error, Bonzupi. You did? I think you're good. I think you're good to go. Kyle, this is pretty interesting. So we probably could build an algorithm that would learn. And so what I'm seeing here is, so I see player movements, things like that, which is when the AI hits a certain, so it must have state for the game, right? It needs to know where it is in the game in order to make a decision about where to go next. So those features on input are going to be very critical and crucial. Additionally, I think we should be giving the AI some vision, and I would like to give it some sequence of visions. And so I would create sort of a multi-input model that would have vision and game state data. That's what I would do. Also, it probably doesn't know how to deal with menuing. This game has a lot of menuing that's necessary in order to sort of, win the game. If you want to win the game, you need to menu, apply upgrades, candies, right, to your Pokemon, things like that. So there's probably things in here that the AI would not be able to do. Oh, it's 1812, not 1857. Got it. Ooh, wow. Bonzupi. That's pretty impressive. He gives you the repo in the description. Nice. Hey, Mark Lemon, welcome on in. Good to see you. Happy Tuesday. We got ourselves some Mark Lemon here, you guys. Always clicking that hi button. Appreciate it. Nice. All right. I'd love to actually, would be a really good project. So once we become Pytorch experts and we learn everything, because we know enough already to really start building things right now. What I want to do is I just need to go through and learn every aspect of Pytorch. I need to just ingest it. That's part of my mission here. And I really want to become an expert. That's not just a thing for YouTube. I'm really becoming an expert for real on this channel. It figures out the menus. Oh, it does? But it's an issue. He had some workarounds. Okay, got it. Mission complete. Ooh, very nice. All right. Okay, so how we just go... Okay, let me click button. Okay, here we go. Okay. All right, let's continue on our mission. Check mark it, Steven. We're complete. We got the check marks right there. Hey, MD, good to see you. Welcome on in. It's been a while. It's great to see you, MD. You're one of the early viewers, MD. I remember you from the very beginning when we started streaming. And you've been here on a regular basis too. I see a lot. The foundations on which AI are built are far older than most people realize, and AI is way older than most people realize. I've been tinkering with AI since the Alice in 2006 when you were 11 years old. Really? Whoa, Bonzupi. I was just doing C++ back when I was that age. I wasn't doing any AI. I didn't know anything about it. The Blue Brain Project was the coolest thing you ever heard. What is the Blue Brain Project? Blue Brain Project. What is that? Nice to see you too, MD. Nice. Blue Brain Project established simulation neuroscience as a complementary approach to understanding brain alongside experimental, theoretical, and clinical tests or something like that, right? Neuroscience to understanding the brain by building the world's first biologically detailed digital reconstruction and simulation of a mouse brain, which is right here. Look at that. Right here, you guys. This is biology. This is nature. Nature is winning. This is nature right here, you guys. It's nature's computer. And we are trying to recreate it. Hey, nature made us. And so technically, isn't it nature building computers? It's nature, you guys. It's all about nature. Okay. What's up, Steven? Hey, how's it going there, Scythe? Good to see ya. Welcome on in. Happy Tuesday. We're learning LSTMs, you guys. So we're going on to part 2 now. Let's get started with part 2. You don't know anything about programming? Hello world. Yep. Good old Python, suitable for scraping lyrics and doing massive sentiment analysis to understand. Yep, you could do that. That sounds good, Hoover. You could do that. Didn't they play Doom on the brain cells? Yeah, they did. They did. It's happened. It's a real thing. Sometimes it's just like, why though? Right? We don't know why. We don't know why until we try it, right? Right? It could be we just wanted to try to see what would happen. And sometimes it's like obvious that it's going to fail. We're like, yeah, we knew that was going to happen already. We knew it wasn't going to work. Why'd you do it? We're like, well, I wanted to try just to see. I'm like, well, okay, you tried it now. The Blue Brain Project was discontinued in 2023. Was it? Whoa, you guys. Whoa. I'm surprised on this poll, you all said 100%. That's amazing. Okay, let's continue on with our tutorial here, you guys. Let's keep going. In this section, we'll use an LSTM to get part of speech tags. We will not use This is where we got sidetracked on Viterb. Viterb could be used after you've seen what is going on. Okay. In this example, we also refer to embeddings. If you're unfamiliar with embeddings, you can read up about it here. Let's do a quick little scanning on embeddings. Word embeddings, encoding lexical semantics. Word embeddings are dense vectors of real numbers, one per word. A vector of real numbers. Okay, so one vector per word. One vector per word. That's a lot of data in your vocabulary. In NLP, it's almost always the case that your features are words. That's right. That's what the features are. That's the input. How should you represent a word in a computer? You need to give it numbers. You could store it as an ASCII character representation. That only tells you what the word is. It doesn't tell you much about the context or what the word means. You might be able to derive its part of speech from its affixes or its properties from its capitalization. Not much else though. Even more, in what sense could you combine these representations? Right? Engrams we invented in 1947. Perceptron. Oh, the perceptron was invented in 1957. These are some of the earlier AI algorithms. the perceptron. MLP, you guys. I think the perceptron is where backpropagation comes from, and it's the technology on which most modern AI is built. It is. It still is. That's what we got today. We got ourselves the perceptron. You just picked up on your chair, and now you're speaking my language. Oh, hey! For word embeddings for NLP, is this what's going on right now? Is that what you got excited about? You say lexical semantics, and I say when and where. So that's embeddings, right? So you can get an embedding model, a really good one. You can go to Hugging Face and look for the embedding models. Where are we at here? So models, I think you click plus here and you say embed. Well, where is that at? Maybe we can search for it. We can do a quick search here. Here we go. Here's a bunch of embeddings. So you can use this to create a semantical similarity, and it allows you to tag and classify. So you can create your own tags and do some classification that way. So this is the one I recommend because it's a really good one, and it supports 100 languages. It's called Embedding Gemma. It works really well. I'm using it myself. I use this myself. I could classify your own word. You sure could. Yeah, you could classify it. And so what's great is it allows you to create like a cluster of words and then get words that other people, like you were saying, everyone has a different description of an item. And so what you can do is you can create class or tags that represent meaning. And you can create a cluster of words. Someone else can use a different word. However, it's similar or nearby these other words like synonyms and versus an antonym. And you can even use subtraction, right? So you can get antonyms and synonyms for the words that people use in different languages. The symbols. You don't want to use it. You just want to study it. Got it. All right, no worries. You can... Understood. Should you go with a Mac Mini or something else? I like Mac Mini. I think it's a good deal, right? A Mac Mini is going to be a really good deal. It's going to be really fast. You might want to get more memory. Get as much memory as you can. And the Mac Mini is just going to be really fast. And it's a good price, right? So I think that's a really good deal if you can do the Mac Mini. Or if you want to go a step up, you could get a MacBook, but the CPU is going to be throttled due to thermal throttling. It's not as good. It's got heat pipes in it, though the Mac Mini is going to be a little bit faster because it's got more. It can hold a higher temperature. It can deal with a higher temperature. Okay. So let's keep going, you guys. Let's read through the rest of this here. The model is as follows. Let our input sentence be word to word M, where W and the sum of the vectors are vocab. Okay. Also let T, our tag set, and Y, the output of the tag word, denote our prediction of the tag of the word. This right here, not that helpful. No. Hey, how's it going there, Brigitte Limited? Oh, Brandon, good to see you. Brandon, remember your name there, Brandon. This is a structure prediction model where our output sequence is a bunch of numbers. Is that a magic spell? It looks like it, doesn't it? It looks like a magic spell. It's giving you some math placeholders, variables, right? So word 1 to word M, so it's an array of words. And where the vector, you're going to have word, and then I believe this is sum of vector, or vocab. Let T be our tag set. So it's defining variable names is what you got. What you got for Easter? Good question. A lot of conversation, I think is my answer. What do the predictions, right? I get it. You do? I mean, I somewhat get it. I get it a little bit. Pass an LSTM over to the sentence. To do the prediction, we pass an LSTM over to the sentence. Denote the hidden state of the timestamp or time step. I is H. Okay. Also assign each tag a unique index. How we had word, right? We get to create a dictionary. Word to index in the word embedding section. Then our prediction rule is, this is our prediction right here. This part I don't understand, and I need a solid answer on this right here. This is very weird. I get it from a backpropagation gradient generation. You got nothing? Hey, don't worry. You're it. Just a smidge. This is what we need to understand here. All right, so I need to ask an AI this question. Can you go here? Okay. Paste. Okay. We need to know, is softmax necessary during inference? I don't think so. I think the answer is no. See, I told you! I knew it right there! I'm like, what are you doing this for? Strictly speaking, no. Softmax is not necessary during inference. Only if your goal is to find the most likely class. All you need is argmax. Right there! See, I told you! See you, Steven. It's 12 a.m. here. All right, got an interview in the morning. Good luck in your interview. We'll see you next time. See, I told you the whole time. And then I post this on like Instagram as a reel, and people are like, no, you gotta use it. You get the softmax. It's for blah, 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 blah. You gotta have the softmax. Like, yeah, I know the softmax can be as an activation. You don't need it during inference though. It's in the tutorial is showing you here as part of inference. It needs to describe, you gotta use this part for your backpropagation because it helps collapse the output gradient so that way it doesn't explode when you do backpropagation. When I was always asked AI something, it talks in Estonian, and then I'm like, what is this nonsense? Does it? Softmax looks max. It is! Hey, Loons! Good to see you over there on purple. So someone mentioned this on one of my YouTube shorts. I mentioned the word softmax in the YouTube short, and they're like, this isn't what I was looking for. I was looking for looks maxing. They were about looks maxing, right? Where it's about like changing how you look to like increase your booty. Lols maxing, right? Lols maxing! Get the lols maxing! Knock knock. Who's there? Lols maxing. I like that one. Go away. Wisdom who? All right. I knew it the whole time. I feel vindicated. Okay. That is, it takes the log softmax of the affine map of the hidden states, and the predicted tag is the tag that is the maximum value of the vector. Yeah, I know. This is exactly how the output works on BERT and ChatGPT and OpenAI. Oh, the good old Claude codex. And the Geminis. Watching on Stream Deck. Nice, better quality, and your phone for chat. Hey, on Steam Deck. So we're on TV. We're on the big screen. We're on the big screen. Knock knock equals go away. Oh, does it? Well, the more we know. Let's prepare our data, you guys. Let's prepare our data. Okay. Okay. Prepare sequence. Sequence 2ix. What is 2ix? It's our dictionary. 2ix? It's our dictionary, right? This is our dictionary of words. It's cardinality, right? Word cardinality. Our what is that? What is that library system that indexes books by ID, right? It's an indexing system. What is that library? Library book indexing name. What is the name of the system? Yeah, alphabetical list. No, we know that. What is the name of the system? The name. What is that? I saw your video about tech news. You bringing that back? Oh, yeah! I saw that video posted. No, probably. Wait, maybe. All right, so the plan is maybe. So if we ever do full-time streaming, we might do games, right? And we might do tech news, and we'll also do coding. However, right now, the plan is just to learn Pytorch for now. And that's the streaming that we're going to do here. The primary system for indexing, classifying, and organizing books and libraries is called the Dewey Decimal Classification System. That's what it is, Dewey Decimal. Okay. That is the right word. However, it's not really what I was looking for, even though it's what I searched for. My TV was taking too much noise. Nonsense. It turned. Oh, you talked and was speaking Russian? What nonsense? You're American? That would be cool, Kyle. It would be. The Dewey Decimal System. Yeah, because what we're doing right now is we're creating an index. That's why I was talking about that. We're creating a word index. Not a book index, a word index. This implies, all right, so note this implies immediately that the dimensionality of the target space, A, is of T, our tag set. This is the output. How many tags are we going to have, right? We're going to have 10 tags. That'll be the dimensionality of the target space. The target space, you guys. How's it going there? It's a little toilet. Good to see you here. Welcome on in. Good to have you here. All right. Training data. The dog ate the apple. Hey, we said what our favorite fruit is. What's this? What's this right here? What are these? Hey, tutorial. Tags? Oh, they're tags. For the word? Tags are determine, noun, and verb. Determine, noun, verb, determine, in. Huh. Okay. Now, Lil Toilet is going to feel bad. Oh, really? Oh, no, Sam. I was about to call that out. Mod who deleted that rude comment. Oh, yeah, Bonzupi, thank you. Thank you, Torva. No, just banned. All right, straight up ban. You get the heavy hammer. Got the heavy hammer on that one. You get the heavy hammer. Straight banned. All right, everybody read that book. Gonna be book V. All right, so these are the tags. So we're gonna have two indexing systems. Let's read through this. See, I told you. Right there, right there. It's the dictionary. See the dictionary, you guys. It's a word. Word to IX. Sent tags and training data. Sentence. Oh, this is a sentence. Okay. He banned Lamau. Zero tolerance for dropping slurs. Exactly, Banzupi. You get no chances. You get no chances. See, this is the index right here. Remember we created this yesterday? Remember we created that yesterday? I was like, hold on, you guys. This is broken. All right. No, I got to show you. All right. Where was that? Vi recurrent. See right here. Right there. Tokenize our vector. We did it right there. See our words. We created our own indexing system right there. And we're using dictionary comprehension to do it. And as you can see, we get ourselves the dictionary. And also they have tags here on the output, which we need. However, I think this is going to be a one hot on the output. Are we going to rechange this? So this will vectorize. You can do it like this if you want. You can do it like this if you want. Although I would, instead of, I mean, if you're gonna automatically do this, why create your tags like this anyways? Why not just say noun? Just say noun. Why have a? This doesn't make any sense here. This is very odd. There's no need for this abstraction here. I call shenanigans. You guys, I'm calling shenanigans. Just create the word. I mean, you don't need this what do you call it? You don't need it to be. You just use the word determiner. Just use the word determiner. Hey, how's it going there? Laudin Legion. Welcome on in, Lond Legion. Good to have you here. Thanks for saying hi. Because it's like playing Dungeons and Dragons. Oh, it is a little bit. Get some RNG in dice rolling. Why was the crow thirsty? Because he needed water, I guess. Sam? Okay. What are you working on, bro? Lawand. How's it going there, Lawand? Lawand, we are building ourselves an LSTM today. And we're going through the stages. We're going through the stages on it right now. Bro's trying to teleport water into Mars. Just a little bit, right? Just a smidgen. I'm out of water. Uh-oh, you guys are out of water. Okay. Let's do a little bit of data prep here, and then we'll I think we'll start. This This will be like the wrap up here. All right, ls here by, this is example LSTM here. We're gonna do some data prep. Although, you know what? Let's do a full LSTM. I think we're getting into the full LSTM part of things here. Yeah, we are. All right, cool. Thank you for the hearts, you guys. Thank you for the reactions. Yeah, but the crow on Mars needs that water. The crow on Mars needs it. You got it. How's it going there, Handy? Good to see you, Handy fan. Welcome on in. So let's create our prepare sequence. I don't like how they're doing this though. I want to do it differently. Sequence to IX. So we got our 2 IX in here for the sequence, which is fine. So let's do a dictionary. So let's get our training data first. Let's create our training data. We're gonna create our own training data here. Okay. Vi ls full lstm.py. Full, please. Python. Full LSTM, please. Oh, we didn't save it. There we go. Okay. Import torch. Import torch.nn as nn. We import torch.nn.functional as f. Import torch.optim as optim. Bro's locking in. You know we're locking in now. Whoop. Oh, close that out. All right, let's open that again. All right, so we need to do our training data. Training data equals. Now, we're gonna do something different. We're gonna change it up here. We're gonna do it the way we want to do it. We're gonna follow the tutorial. We're gonna make some changes though. All right, so let's go here. The dog ate the apple. We should probably do lowercase. And we should probably do a few other things. And then we're gonna have our so this training data, so features and labels. Our features and labels, which we'll extract this later. We'll extract it later. So we'll say determiner. This is noun. Determiner. And noun, right? I think that's it right there. So that way we keep everything easy to understand. We don't need any like symbolic stuff in. You made images to explain what's happening on your internet and workflow from yesterday on link share. Nice. Oh, StreamCode worked today. Oh, good. StreamCode did. Can we get a room tour? Very poetic words. There, yep. Someday we'll do a room tour. You can kind of see. I mean, it's basically the office, right? So you can. There's not much here. Over there on that side of the wall is all the networking equipment. And then on that side is just another desk. That's all that is. There's not much to see. You're probably going to go to McDonald's, get a McDonald's job application? Well, they pay pretty well. I hear they pay pretty well. You don't know where you're going with this anyway. Hey, Sam. So, like, no water there. There's no water, right? The crow is on the other side. But it's already there, though. It's already there. The other one is the crow. All right, you know what? I've got your answer. Like the one where the crow is going. There. All right, there we go. So let's see if we can do it. Like, I don't even know what that is. Is that a word? Like? Is it a determiner or what is that? A verb. 8. We forgot the verb. Verb. There we go. F, come on, go. There we go. The crow can fly to the water. Let's do that one instead. I like that one. All right. Thank you. The crow can fly to the water. All right, so we got a determiner. I know that part. And then we've got a noun. And then we've got a verb. Are these verbs? Is can a verb? What is can? I should know this. I feel like a human should know this. Can, verb or noun? It's like neither. It's an objective. is both a verb and a noun. Oh, okay. Verb. Verb. What's 2? Wait, I'm just arguing nonsense. Oh, what are you trying to do, Steven? We are creating training data for our input model. So, Bonzupi, I liked your training data. I think it's pretty good. Yes, like a verb. Whether the term is like officially recognized as a noun yet. I don't know. You're cracking up? We're making our way. Let's see. All right, so the crow can fly. Ignore phone. Okay. Don't worry about that sound, you guys. Okay, let's see here. The crow, determiner, noun, verb. What is 2? Is that another verb? I'm just going to call it a verb. I don't care. And this is another determiner. And then we have a noun. There we go. Okay. We got our training data, you guys. What sound? What's the sound? What if the crow is dehydrated? Could it just glide at some point because of being so light? Yes? Isn't that true? Yes? Can of soup is a noun. Yep, exactly. Can I eat is a verb. Can I eat that can of soup is a noun and a verb. You got them both. Jacob, you got them both. Jacob Crosby. You didn't hear anything? Oh, the sound. Yeah, that's the phone ring. That's the phone ringing, which I just ignored. It was spam, probably. You've got more. Oh, hey, Chris Flores. Thank you for subscribing. Welcome on in. Good to have you here. You joined the right channel for software engineering. You've got me into the Tamagotchi car version of the Android or Arduino Uno. What are you doing with the Tamagotchi car version of an Arduino Uno? Hey, technically, I'm curious about what you're doing over there. Here's another one. Why was the dog barking at night? Because he needed Red Bull. Wait, like the beverage? Oh, he needed Red Bull because of the caffeine? You didn't hear it either? It was because the music was pretty loud, so it drowned out in the music. You know what a Tamagotchi key yep. It was like a monochrome LED screen, like Tamagotchi it. And you got to make sure you give it all the right stuff, and you got to feed it. The car version is on Arduino Uno. Is it? I didn't know that. I mean, it seems like you'd want a Tamagotchi running on a very specific hardware. You wouldn't want it running on application, you want it running on a dedicated processor that was intended for the game, right? Because it's like hardware and software all at once. And so having something like an Arduino Uno is too general purpose. That's the word I'm looking for. You made this? Did you? Oh, okay. So if you made a Tamagotchi on an Arduino Uno, that's fine. That makes sense. I gotcha. So you wrote some software that became a Tamagotchi on the Arduino Uno. Sir, right now I'm struggling to face anti-spoofing on Kaggle. Do you have any advice for me on spoofing on face spoof image? So you're doing some image recognition, is what you're doing? Do you have any advice for face spoof image? Yes. So I've got a little bit of advice. When you're looking for fake AI generated faces, you're going to look for a specific pixel bloom effect, right? You don't need to know what that is. You can train an AI to do this. So I recommend building a convolutional neural network model that's going to look at small snippets from the AI, from the input image. You'll take segments of the image and you'll put it through the model. So say you've got a picture of a cat here, right? Here's all the pixels of a cat. You need to see the raw pixels, but there's too many to put through in an AI model. So what you're going to do is you're going to capture a few of the pixels at a time. So you'll gather just a segment, and then you'll grab another segment of those images, and then you'll scan through those. You will be doing this differently than a full-on CompNet because you're doing this with your input training data. You'll get real pictures, real photographs of humans, and you'll compare that to AI-generated pictures. You need to curate a data set. You'll have the AI train and look for the bloom effect that occurs in AI-generated models for the image outputs. That's what I would do. That's what I would do. The Bloomberg, exactly. You could use AI to make your own training data. You could do that too, right? You could do that too. Did you hear about the new JavaScript library that reinvented the way that the browser handles text? Yes, I did. Pre-text. That was really neat. In order to do that, they had to create the font, kerning, and the placement of the glyphs needed to be trained by running it through a whole bunch of millions of samples to understand where the glyphs can be placed from a pixel perspective. So it works. It works. I don't know how it works for different fonts, but it works with certain fonts, that's for sure. It sounds like he's trying to spoof the face to circumvent the identity verification on Kaggle. Oh, so he can make multiple accounts. Is that what it is? That's not what I thought you were talking about. I was thinking you were talking about something constructive. I didn't think you were talking about nefarious activities. Kaggle terms of service only allows one account per person. Got it. Why would you want more than one though? You have advice for you? It might sound crazy. Won't it make sense to sleep instead of writing? What? Yes, in some cases. Hey, how's it going there? Manny, good to see you, Manny. Welcome on back. Hi, Stephen, how are you? We're doing really good. We are going through Pytorch, and we got our training data, and we're going to create a dictionary of our training data, which we did yesterday. So let's do a little bit more of this here. Let's do a little bit more. So let's create our dictionary. Our dictionary equals, right? And then we're going to have our tags. And we're going to predefine our tags here. We're going to predefine our tags. How do we do that? We only have noun, verb. Is there another one? 1, 2, 3. That's it. We have 3. We have 3 types. Nouns, verbs, and determiners. The reason why you might want more than one account on Kaggle is because Kaggle gives away generous amounts of free GPU. Okay. Gotcha. I'd love to show you the Tamagotchi card code. It's neat. Sounds good. Hey, technically, throw that on Discord. Throw it on Discord so we can take a look. I'm going to take that advice. Thanks. Torva, you've got good advice. That's what's going on, Torva. I get it now. You were talking to Sam. That's why. I'm like, I don't get it. Okay. So, I do see a potential bonus to creating a symbol for this. Although, why not just use a single letter? Why 2 letters here? Alright. So let's capture this here. We're going to do some capturing. Alright. You know what I'm going to do? I'm going to do dictionary comprehension. Let's do the WI for IW in enumerate. Like that. There we go. And we got our tags. Print our tags. There we go, right there. Let's see what that looks like. Full. Where did we go wrong? Oh, little teaser right there. Little teaser. Okay. NP, 2 days without sleep is a bit too much to not sleep. It sure is not. Yeah, I'm gotta be careful there. Sir, I really like learning machine learning, deep learning, or AI, and I often practice on Kaggle. For what makes a good ML or DL engineer? Knowing the algorithms and the different approaches that you need to take for optimizing that pretty gradient, that beautiful smooth gradient. You need to make sure all of your gradients are smooth. Basically, all your parameters and features need to have the ability to provide generalization and give you really good quality output on things that it's never seen before. So you need to have a set of understanding about which algorithms to apply under which circumstances, which is mostly what we're trying to learn here on this stream right now as we're building an LSTM. Vectorizing data, encoding, decoding. A good portion of a strong AI engineer is knowing how to deal with data, because about more than 50% of AI is preparing your data. So that's a good part of it as well. So you get data and the algorithms. Of course, I mean, maybe the only thing that wasn't obvious was data prep in what I just said. You're like, Steven, of course the math makes what AI is. Gotta love the data, you sure do. All right, so we got our dictionary and we got our words are here. So we got our training data. Let's build our dictionary. Def build this dictionary, and then we're gonna have our training data. How about we just say data? Okay. So for hold on. So they want it to be a tuple. Okay, X tuple. Because we need this is like together. These are pairs. They're pairs, so they have to be together. Okay. So we're gonna go for let's go D in data. We're going to create this sentence equals D 0, and then we're going to say for W in, this will be the sentence. I always misspell that. Dot split on the space, and then we want to lowercase this. How do we do? To lower. Can we do that? Is that how we do that in Python? Dot to lower. No, that's not it. Maybe it's just lower. Okay, it's just lower. Okay. Okay. Then we're gonna get our dictionary. We're gonna create a new dictionary. All right, so this is gonna be our updater. We're gonna say, how do we want to do this? How do we do this, you guys? Because we're gonna have multiple sentences now, so we have to do it a little bit differently. I don't know why, but loving reading data stats, handling data with the code it's very painful. You're right, it is. We're doing that right now. We're going through the pain. So this is our update, and then we're gonna say W. We gotta do something with W here. Let me say dictionary.update. Update. I think. How's it going there? Dior, how's it going? Set your belt to Rambo. Hey! How do you say your name? Certain? Are you certain? Welcome on in, Certain. Good to see you. Happy Tuesday. All right, we're gonna wrap up here, you guys. I wanna get the build dictionary function done, and this will be the wrap for today. We'll be back tomorrow with more LSTM. Part 2. Really part 3. We'll do part 3. So we're gonna build our dictionary. We gotta do something with our word here. So we got our sentence, we got our word. Yeah, I'm just gonna, there we go. So it's a little bit more obvious what that is. So we got our word. And then we need to update the dictionary with the word and giving it an ordinal. So this needs to be, the problem though, we've got a problem with this though. We've got a problem. We need to get the, we need an offset. We need an offset. That's what we need. We need an offset. Offset equals. Can we do a length and with the dictionary? So we do A1, B2. Do you know if Python offers phone in tech support? Oh, wait. Do you know if Pytorch offers phone in tech support? I still doesn't. Oh, Mark Lemon. Hey, Mark Lemon. All right, I'm going to answer your question because you're a good regular viewer. You're a good regular viewer. Do you know if Pytorch offers phone in tech support? I don't know what that means, though. I really want to answer it. I'm trying to read it. Okay. What do you mean? So, Pytorch phone. You can run Pytorch models on the phone. Call in. You could. Yeah, do you know if Pytorch offers phone in tech support? So you can dial in to Pytorch and say, hey, can you give me some support? Is that what you're looking for? Yes? Really? No way. Why would just use the AI? What a silly question. You want to call Pytorch? I don't think they have a dial-in number. I'm pretty sure they don't. I don't think so. I mean, it's a library. I know, right? It was a joke, I think. Was it? No. Am I a good regular viewer? Yes, you are, Loons, because you're on both platforms. You're a good regular viewer, Loons. You are, yeah. It was a joke. It was? All right. Okay. I wasn't getting. I missed the jokes. Sir, I missed the joke. I missed the joke. I didn't get it. Sorry about that. I'll try better. All right, offset. Dictionary. I need to see the dictionary length equals 2. Okay. All right. Len. Can we do that? I think it's got to have a len. Yeah, it does have a len. All right. Len. Dictionary. So here's our offset. And then we're going to create our update. Update equals. We're going to do that here. Offset plus. Let's see. For word, comma. Yeah, that is word. I need to enumerate this though. Like that. There we go. This will be word, colon, offset plus index. There we go. Index. Hey, look at that. Look at that, you guys. There we go. All right. Here's the update. I think that's it. I think we're good there. Okay. Good right there. Update. Done. Done. I think that's it. I think we did it. We'll do sample. Keep everything in single big words so we know how to read it. Pytorch has a phone tech support, but you have to buy Apple gift cards and scratch off the back to read them. Yeah, exact. Totally worth it, though. It's totally worth it. You seem like you keep on your skincare. Oh, Dylan. Hey, how's it going, Dylan? Yeah, I put on lotion. I do. I put on lotion. Yeah, what is your skincare routine? Gotta put on the lotion. Because if I don't, then my face gets all flaky. Because I move my face around a lot. If I didn't move my face and I didn't talk, I probably wouldn't need lotion. That'd be fine. But if I don't, it gets a little, and it hurts. It hurts. That just might be me, though. Probably because I don't know why. So let's build our dictionary. Let's find out. Build dictionary. Oh, then training data. There we go. Right there. Let's do print dictionary. All right, you guys, let's find out if it works or not. I heard that long short-term memory is the better version of an RNN. What makes it different? So I think the idea is about gradient compression. So it's about gradient compression, right? So how do we represent this? We need a gradient. I don't know if we can figure this out. I don't know if it's easy to tell. So as you increase the number of tokens on the input, right? The number of tokens, it's gonna make this sort of shape here, and it gets more sparse. You add some sparsity here. So the problem with an RNN is that the earlier data gets lost and compressed as you're regenerating the meaning, the output, right? And so you've got like words like I don't know. Let's see here. Can I double click? I don't know. Let's say cat, right? Difficult. There we go. Cat right here. The word cat here. However, if it might not be able to easily see the word over here. That might have been like dog or something, right? D-O-G. Trying to... I have a magic pad, which makes it difficult to draw. What is the point of streaming if you don't talk? I know, right? What's the point of streaming, Loons? You're on both platforms now, Loons. I see it. You need to send your link to a Excalibur file. Can I do that? You need to send a link to your Excalibur file. I mean, it is pretty neat. We've got a lot of stuff in here. We did a lot of things over the time. So this is a problem with an RNN. With an LSTM, it has the same initial problem, but it also has another gradient, which I think helps smooth out that. So that way things are more visual. The AI won't lose data as you're adding more tokens, which means with an RNN, right? Let me type this out. Let me just type this out. So this would be like RNN here. And over here, let's just say LSTM. There you go. Hey, never mind. Fix you. Oh, following. Fix the book. Thank you for following again, I think. Over there on the purple. I'm starter, then AI. So I might have to leave. All right, Mr. Sounds good. Mr. Mittits. So I think this is the problem. So imagine these as numbers. And the numbers are getting squished and more squished in RNN. With an LSTM, it's able to extrapolate a little bit better. So it creates a nice and smooth, right? Nice and smooth. That's the difference from the gradient perspective. So that makes it easier to learn. It makes it easier to give you outputs. And you can have longer context, like longer words, more sentences, more data. You're everywhere, Loons! All right, you guys, we finished it. We finished the dictionary. Oh, wait, actually, I don't even know if it works yet. Let me double check if it works. All right, Python full. And that didn't work there because we might need to switch these around. Let's try that. There it goes. There it goes. Okay. So we got ourselves a dictionary here and our tags. Tags in our dictionary, you guys. There we go. Dictionary right there. And our tags. Much better, much better. Okay, so now you can see what's going on here. So we got a dictionary, which is going to be the tokenizer, right? It's going to turn, well, it's going to turn our words into numbers, and then we need to take those numbers and we need to probably do something more with them, right? I don't know if we're going to one-hot them or what. I don't know for sure. We're going to find out tomorrow, though. We're going to find out tomorrow. Thank you, everyone, for joining. We'll be back tomorrow about the same time, I think. Maybe a little bit later. We'll see. We'll see. And the plan for tomorrow is we're going to continue our LSTM and we're going to become Pytorch experts. Bye, everyone. And good to see ya. Back tomorrow, everybody. See ya. Have a good one. Thank you for the likes and the party poppers and the 100s. See you later, bro. See ya, Bonzupi. See ya, Alpha. Japa. Bye. Good to see everyone. See ya, Torva. See ya, Kyle. Have a good one, everyone. Dylan, Mark Lemon, Loons, good to see ya. Back tomorrow, you guys. Been a pleasure. All right. See you guys back tomorrow. See you, everybody.